Good evening, everyone. Can you all hear me? Can you all hear me and can you see the screen clearly? So please type in the chat box. So I hope things are clear so far. And can you all hear me? And can you see the screen clearly? So please type in the chat box. Yes? Okay. So if you quickly recall previous lectures, this is a cumulative session. So here we'll be trying to recall all the topics that we discussed right from the beginning of this course to the topic that we covered till yesterday's class. Okay, basically the complex integration. So now, just a second, guys. Let me have these comments here. Yeah. Okay. So now, if you see in the beginning on the first day of the class, we started with single variable calculus. So I request you, if you are writing the notes daily, so please turn the pages along with me. Okay. When I'm saying a particular topic, you try to look into that particular topic. Okay. So in the first class, we started with the concepts of related neighborhood, and we have also seen what is a concept of limit and concept of continuity and concept of differentiability basically. So in limits, we have given some standard limits so that you have many useful formulas in limits. And after that, we dealt continuity and we have seen what's the governing condition for the continuity of a function, correct? And I told you for the function f of x to be continuous, if this is a single variable function, if f of x is a single variable function, yeah, if f of x is a single variable function, for continuity of this function at x is equal to a, we have the condition limit x tends to a, f of x is equal to f of a, correct? We have seen this. This is the mathematical condition for this function f of x to be continuous at this point x is equal to a. Similarly, we have seen what's the condition for differentiability of a function. Like for example, if you want to differentiate this function f of x, then we have defined something called the first principle of differentiation by this particular formulation, f of x plus h minus f of x divided by h when this h tends to 0. Means whenever this h is very small, this definition gives you the concept of differentiability. And then we have seen if this limit exists, then we say this derivative of this f of x exists, correct? This is what we have seen. And after completion of differentiability, we have seen something called mean value theorems, where we have seen the most standard Lagrange's mean value theorem, which is given by f dash of c is equal to f of b minus f of a divided by b minus a. And we have also seen why this formula is sitting here and what's the physical meaning of this, correct? We have seen what is the physical meaning of this particular formula, and then we moved on to something called Rolle's mean value theorem, which is a special case of Lagrange's mean value theorem. Then we moved on to Cauchy's mean value theorem, which is again a special case of this Lagrange's, and then we moved on to the concepts of maxima and minima of single variables, correct? And before going for that, we have also seen Taylor series expansions. So Taylor series expansions we have seen for any differentiable function at any particular point, and also we have seen this Taylor series expansion for many functions like exponential functions, trigonometric functions like sin x and cos x, etc. Correct? So we have seen all these Taylor series expansions of this f of x. Then we moved on to the concepts of maxima and minima using this Rolle's mean value theorem, and we have defined for any function to have a maximum or minimum at a particular point, its derivative should be 0. But I told you again, if derivative is 0, then you can't mandatorily tell that the function has a maximum or minimum. But if the function is having a maximum or minimum, then definitely the derivative is 0. This is what we have seen. And also we have seen the second derivative test, where for attaining maximum, you should have, if x naught is the stationary point, then f double dash of x naught should be less than 0 to have a maximum. And also we have seen f double dash of x naught to be greater than 0 to have a minimum. And of course, whenever this second derivative is 0, we say that the second derivative test fails, and we have seen some of the graphical ways of solving for maxima and minima. Okay? So once we stopped with maxima and minima, we then stepped into some integration. Okay? We have seen some fundamental theorems of integration basically, and I told you if you are writing integral a to b f of x dx is equal to capital F of b minus capital F of a, then this capital F of x is the antiderivative of this basically this small f of x. This is what we have seen. And also once you have seen this, we have stepped into mean value theorem of integration. So the mean value of theorem of integration tells us this f dash of c is nothing but, this is f of c, this is f of c, and this f of c is nothing but integral a to b f of x dx divided by b minus a. Can you all recall this? Did we discuss this mean value theorem of integration? Just a second, this comments I am not able to read today because of some issue, I guess. Let's please give me a moment. I need to read your comments. Okay, so Yeah, things are fine now. So if you can quickly recall, we have seen the fundamental theorem of or the mean value theorem of integration, and this is what we attain as at any point in the interval a comma b, definitely there exists one value of c such that this condition gets satisfied. And we have also seen why this condition is coming here based on some geometrical analysis. Correct? Then we have seen different definite integrals, how to calculate them, and definite different properties that govern the different definite integrals. Correct? And once we have seen that, we have seen how to calculate area between the curves, and we have calculated what's the area bounded between different curves and all. And once we are known with this, we have seen something called the improper integrals, and we have seen what are the kinds of this improper integrals, basically the first kind and second kind. And then we have seen two special type of functions, which are the gamma function and the beta function. Correct? Can you all recall this? Gamma function and beta function. We have seen this. Of course, gamma function at n is denoted by integral 0 to infinity e power minus x into x power n minus 1 dx, and this value is nothing but n minus 1 factorial. So this is what we have seen. Similarly, this beta function, like is denoted by beta of m comma n, is also integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx. This is what we have seen. And of course, this beta function definition is also given by this gamma of m into gamma of n divided by gamma of m plus n. This is what we have seen. Correct? So once we finish this, then we have seen applications of single variable integration. So basically, in applications of single variable integration, we have seen how to find volume bounded by volume of a solid obtained by evolving a curve around any particular straight line. For example, if there is about any axis, so if you have any axis, then if you evolve any curve in some random curve, y is equal to f of x, maybe about x axis or about y axis, we have seen what are the formulas for volume of the solid generated, and we have also seen what are the formulas for surface area generated. We have seen these things, and then once we finished this single variable calculus, we then moved on to multivariable calculus. Basically, there we dealt with functions of 2 variables and 3 variables. Yes. So now, once we step down to multivariable calculus, then we have seen limits in 2 variables, and of course, how does a neighborhood look like in a 2-dimensional plane? In a single dimensional plane, of course, if this is a, then if these are the values of delta, then definitely this interval, which is x minus delta to x plus delta, this interval is taken as a neighborhood. But of course, in a 2-variable calculus, since you are having a coordinate system, and if you take any point, then definitely there comes certain region within this around this point, that is the neighborhood of this particular point x naught comma y naught. Then after seeing this, we have seen what is continuity in 2 variables, and then we move on to something called partial derivatives. Correct? Basically the differentiation. So see here, So see here, now in case of this partial differentiations, we have seen if f is any function, then how to differentiate this function with respect to the independent variables involved in that function. And then we have seen something called the Euler's theorem, which tells us that if f of x comma y is a homogeneous function of degree n, so if f of x comma y is a homogeneous function of degree n, then definitely x into dou f by dou x plus y into dou f by dou y. What could be this value? Can anyone tell me? Can any one of you recall this and tell me what could be the value of this? Whenever this f of x is a homogeneous function of degree n, x into dou f by dou x plus y into dou f by dou y is nothing but n times of f. Good, Kalimullah. So n times of f. This is what we have seen, correct? So after seeing these partial differentiations, we have stepped on to the most important and easiest topic, multiple integrals, correct? So in multiple integrals, we have seen how to write the limits on a double integral or maybe a triple integral if it's given. So whenever you have a function f of x comma y, dx dy or dy dx, depending upon the limits that you write here, we have seen how to write these 4 limits. And of course, we have learned one very important concept, which is the change of variables of integration, correct? Or the change of order of integration as well. We have seen that. So once we finished this, we looked into the concepts of maxima and minima of 2 variables, and then we have seen the concept of Lagrange's multiplier whenever the given function, means the variables involved in a given function, are governed by certain constraint equation, correct? So this is what we have seen, summarily in single variable calculus and in multivariable calculus. So once we are done with single variable calculus and multivariable calculus, now we are in a very good position to solve some differential equations, correct? Because to solve a differential equations, the major art is, you should know how to integrate some function. So if you know how to integrate this, then it's clear we can go for differential equations. So we have started with the definitions of order and degree of a differential equation, and then of course we dealt only ordinary differential equations. So partial differential equations, we have a separate slot for that, okay, at the end of this course, which was already given in the schedule, so no issues. So now if you see in differential equations, we started with the definitions of order and degree of a differential equation. Then we moved on to how to form a differential equation. Correct? So we have seen if the number of arbitrary constants involved in the solution are n, then definitely this n is nothing but the order of the differential equation. This is what we have seen. Correct? Then we have started solving first order differential equations. So in first order differential equations, we have seen different methods, basically like the variable separable method. Then after we have seen how to solve a homogeneous first order differential equation and how to convert a non-homogeneous first order differential equation to homogeneous and then solve it. Correct? So finally we have seen something called the Leibniz linear equation in first order differential equations. So the Leibniz linear equation is of the form something like dy by dx plus p times of y is equal to q, where of course this p is nothing but a function of x and this q is also some other function of x. So if both p and q are functions of x, then definitely we have the integrating factor if is equal to e power integral p dx, and we have the solution as y times of e power integral p dx is equal to integral q times of integrating factor, so e power integral p dx to this whole dx plus a constant. So this is what we have seen as the solution of Leibniz linear equation. Then after we have seen how to convert some special kind of non-linear equations to linear equations. Correct? So basically if there is any equation of the form f dash of y into dy by dx plus f of y into x is equal to q something, then if you take this f of y as some function p, then definitely this term could go to dz by dx and all. So definitely, okay, this is not p, so this here you are having some function p. So if you take this as some variable z, then definitely this is dz by dx, and definitely then you can have here basically this conversion to linear Leibniz equation. Okay? So we have solved these Leibniz linear equations, and then we moved on to something called higher order differential equations, where whenever we have a higher order differential equations which are governed by some operator operating on y is equal to again some function of x. So we have seen how to calculate the complementary solution and also how to calculate the particular integral, and then we combined the two things, and then we have written the complete solution of the differential equation. Okay? This is what we have seen, and of course depending upon the capital F of x that lies here, we have seen different methods how to write the particular integral. Similarly, by looking at the roots of this auxiliary equation, we have also seen how we can write the auxiliary or the complementary solution of this differential equation. Okay? Can you all recall this? Yes or no? So please respond. Can you all recall these things till this moment? If you can recall till this moment, I'll go for the next parts. Okay? Yes, Jitendra, good. Okay, good, Divya. So now, if you can recall till this points, then after this, we have started solving what is a Wronskian and what is, Cauchy-Euler's equation and Euler-Cauchy equation and all basically. And then we finished this differential equations and we moved on to some very interesting topic, which is the vector calculus. So in vector calculus, we have in the first beginning, we have seen what is a vector and what are their properties. Correct? We have seen vector and its properties. So basically we have seen some cross product, dot product means multiplication of two vectors, addition of two vectors and subtraction we have seen already. So now after seeing vector properties, we have stepped into the vector differentiation part. So means basically we have seen vectors and then we started seeing vector point functions and of course scalar point functions. So we have defined what is a vector point function and of course what is a scalar point function as well. So in vector point functions, we have defined one thing. Whenever this vector point function, let us suppose r bar of t is of constant magnitude, then definitely this r bar dot d r bar by dt is 0. This is what we have seen, and of course this is the case at constant magnitude. And after this, we have seen whenever this vector has a constant direction, then definitely we have seen this cross product of this vector function d r bar by dt is also 0 bar. This is what the two important conclusions that we do from this vector point functions. So once we have seen this, we step down to differentiation of this vector point functions, where we have seen the definition of a gradient, curl and divergence basically. So here we have seen how different things could look like with the help of the divergence operator or the del operator. This is denoted by del operator, and we have seen this del operator is nothing but dou by dou x of I bar plus dou by dou y times j bar plus dou by dou z times k bar. So with the help of this del operator, we have seen what is gradient, what is a divergence and what is a curl. Once we have seen what is a divergence, curl and gradient, we step down to the vector integration. So there we have seen three special kinds of integrals: the line integrals, and of course the surface integrals, and the volume integrals. And we have one more thing, which is volume integrals. Okay, this is what we have seen. So we have seen evaluation of these three integrals individually, and also we have connected these line integrals with the surface integrals using Green's theorem, and also the surface integrals to volume integrals using Gauss divergence theorem, and all these things. And of course, we have also seen something like Stokes theorem. Okay, so we have seen this Stokes theorem also, and these are the three basic theorems that governs using vectors. So these three theorems are taught in this vector calculus. So they connect, these theorems basically connect two of these three integrals. Okay, this is what we have seen. So once we are done with this all kinds of integrals, so we basically looked into vector differentiation and also vector point integration. So now once we finished this vector calculus, we moved on to something like complex calculus. So in complex calculus, we have seen the basics of complex numbers and their different properties. So we have seen how any complex number can be converted into a modulus amplitude form, and we have also seen if two complex numbers are multiplied which are having theta 1 and theta 2 as arguments or amplitudes, then definitely we have seen what's the argument of or what's the amplitude of this theta z1 into z2 and z1 divided by z2 and all these things. Correct? So once we have seen all these things, then we moved on to something like complex functions, and then we have seen what is an analytic function. Correct? So for a function to be analytic, it should be differential at that particular point, and also it should be differentiable in the neighborhood at every point in the neighborhood of that particular point. So once we have seen what is an analytic function, we have seen what are the mathematical conditions that govern this analytic functions. For example, we have seen the Cauchy-Riemann equations, of course, both in Cartesian form and also in polar form. Okay? So we have seen what are Cauchy-Riemann equations, and then we stepped on to the complex integration part. So once we stepped on to the complex integration part, we have seen few important theorems like the Cauchy's integral theorem, which says that whenever you are integrating along a closed path, if this f of z is analytic throughout the region in this closed path, then definitely this integral is equal to 0. And also we have seen Cauchy's integral formula, which is given by whenever z is equal to z0 is the only stationary point, then this phi of z divided by z minus z0 whole power n plus 1 dz, this is equal to 2 pi I times nth derivative of this phi at z0 divided by n factorial. So this is what we have seen, and this is the Cauchy's integral theorem. Okay? And in yesterday's class, I have also shown you, in the day before yesterday's class, I have also shown you how this Cauchy's integral formula can be deduced from this Cauchy's residue theorem. So now after defining this Cauchy's integral formula and Cauchy's integral theorem, then we have stated what are poles and singular points. So in poles, we have seen what's the order of a pole and all these things. In singularity, we have seen essential singularity, removable singularity, and of course an isolated singularity. So once you know these singular points, then we have given a common formula for finding residue, where residue of f of z whenever this z is equal to z0 is a pole of order m is nothing but 1 by m minus 1 factorial into limit z tends to z0 of d m minus 1th derivative of this z minus z0 whole power n whole power m into phi of z divided by z minus z0 whole power m. This is what we have seen, and of course the total value is nothing but the residue of this f of z at z is equal to z0. So based on this, we have solved good number of questions in yesterday's class, and then after completion of this, we have stepped on to Cauchy's residue theorem. So once you know how to find the residues, we have calculated residues at all the singular points, and of course we have given the cyclic integral of f of z dz is nothing but 2 pi I times of summation of I is equal to 1 to, okay, let me write j because you may get confused again. So j is equal to 1 to k residue of f of z at z is equal to zj. This is what we have seen, and of course based on this we have again calculated some few complex integrals, correct? And then we ended the topic of this complex integration after dealing this Lorentz expansion series, correct? So in Lorentz series we have seen how the f of z, if it's analytic at any point except at z is equal to z0, then how to expand this f of z about the point z is equal to z0, and we have seen what are the analytic parts and what are the principal parts, correct? So can you all recall all these things now till this moment? Yes? So can you all recall this till this particular moment? Are these the things that we covered so far, right from the beginning of this course to till this moment? Yes? So if you are writing your notes, you can please refer each and every page, and you can see all these things that we discussed. Okay. And of course, I think we have already solved some more than 400 to 450 problems. So definitely this could be a good sign for you. So now in today's class, we'll straight away go for solving the problem, since today is the cumulative, and also we have just recalled all the things for 20 minutes nearly. So please try to solve these questions. Okay. So let's go with the first question of the day. Okay. And if you're liking the videos, of course, you please like the sessions and then you can share them among your circles. And definitely you can subscribe to the channel if you are here for the first time, because from tomorrow we are going to start a new module, which is the linear algebra, which is again common to all the branches. So please try to join on time. Okay. So for the time being, let's try to solve this question. The value of f of x at x is equal to 1 when f of x is equal to x square by 1 plus x square and so on, things like this. So please try to calculate this value and tell me what's the answer. 1 Mauli, 1 Divya. Okay, what about others? What about others? So this f of x, okay, let me help you out. So if this f of x is equal to x square by 1 plus x square plus x square divided by 1 plus x square whole square plus x square divided by 1 plus x square whole cube and so on, things like this towards infinity, then definitely good, Akshaya, correct? So now if you take this x square by 1 plus x square common, you will be having something like 1 plus 1 by 1 plus x square plus 1 by 1 plus x square whole square plus and so on, things like this. Now one thing I can tell you very confidently, whenever there is x square in the numerator, in the denominator, this term which is 1 by 1 plus x square will be always less than 1, correct? Because it's clearly given x is a non-zero, so definitely this value is nothing but always less than 1, which means this term which I have written in this complete brackets denotes a geometric progression with a common ratio less than 1, correct? So whenever the common ratio is less than 1 and if you are having the series still infinite terms, then this is equal to x square divided by 1 plus x square into, now the first term is 1, so first term divided by 1 minus this common ratio which is 1 by 1 plus x square. So this is what you have. So if you take an LCM here, x square by 1 plus x square into, if you simplify the terms here, you will be having 1 plus x square divided by x square. Okay, so this is what you will be having. So now if you simplify the things, definitely you will be getting something around 1. Okay, is that clear to all of you? Is that clear? So shall we go for the next problem? I hope things are clear for this question. Okay, it's just a simple simplification that's involved here. Okay, so now let's go for the next problem. So please try to solve this. I hope you have a little knowledge in determinants because I have already covered in my basic comprehensive course. So please try to solve this. U1 is equal to x2 x3 divided by x1 and U2 is equal to x3 x1 divided by x2 and U3 is equal to x1 x2 divided by x3. So they are asking for Jacobian of U1 U2 U3. Okay, so they are asking dou U1 U2 U3 by dou of x1 x2 x3, since U1 U2 U3 are depending on x1 x2 x3. So this is nothing but the determinant of dou U1 by dou x1, dou U1 by dou x2 and dou U3 U1 divided by dou x3 and also dou U2 divided by dou x1, dou U2 divided by dou x2 and dou U2 divided by dou x3. Okay, similarly you have dou U3 by dou x1, dou U3 by dou x2 and dou U3 divided by dou x3. So this is the determinant which is called as Jacobian. So if you could know this, please try to calculate the value and tell me the answers. You know how to partially differentiate the things. Whenever this U1 is a function of x2 x3 divided by x1, then definitely you can write what is dou u by dou x1, dou u1 by dou x2, dou u1 by dou x3 and all. So you'll be getting all the 9 terms. So if you find the determinant value, please tell me what's the value of this. Okay, so please try to tell me what's the value of this. 0. Why? Any reason, Mauli? Why it should be 0? But actually 0 is not the correct answer. Okay, so please try to solve this. So please try to solve this question. This question I have given here because I want you to know what is a Jacobian and how to calculate this, of course. So please try to calculate this. Look, let me help you. Okay, let's solve together. So dou u1 by dou x1 is nothing but minus x2 x3 divided by x1 square. This is what you have. Next, dou u1 by dou x2 is nothing but x3 by x1, and of course dou u1 divided by dou x3 is nothing but x2 by x1. This is what you have. Next, If you calculate dou u2 by dou x1, then definitely differentiation of this with respect to x1. So if you differentiate this with respect to x1 partially, this is x3 by x1, next minus x3 x1 divided by x2 square, and of course we have x2 divided by x1, correct? Sorry, x1 divided by x2, okay, x1 divided by x2, and I think this should also be x2, correct? Yeah, this should also be x2. Similarly here in the third term, if you are having this u3 as x1 x2 divided by x3, then the partial derivative of this term with respect to x1 is x2 by x3. Similarly, whenever you are differentiating with respect to x2, this is x1 by x3, and also the last term could be something like minus x1 x2 divided by x3 square, correct? This is what you have. Now if you make little simplification, this determinant is very easy to calculate. Look, I'll tell you how. Whenever you have x1 square here, shall we write an x1 and square here? Similarly, can we write an x1 and a square here? Yes or no? Can we write it? Next, if you are having this x2 here, we can write a multiplication of x2 and a square here. Similarly, there is a square here, and here let us make a multiplication with x2 and a square here. So here in the first term, you have a common denominator of x1 square throughout. In the second term, in the second row, you have a constant denominator of x2 square all the time. And similarly here, if you are doing it with x3, again, this is what you can have. Now tell me one thing, can I take x1 square common from this first row and x2, 1 by x1 square and 1 by x2 square and 1 by x3 square common from all these terms? Yes or no? If I can do this, look, let me help you out. If I can take this 1 by x1 square into 1 by x2 square into 1 by x3 square common from this determinant, I'll be having minus x2 x3 minus x2 x3 x3 x1 x1 x2. Okay, this is what we have here. If you see, next if you go for this x3 x2 x3 x2 minus x3 x1, and we have x1 x3 here, or 2 x1 x2, I guess. Yeah, x1 x2, correct. x1 x2, yeah, something like this. Again here, if you try to write this third row, then definitely you could see x2 x3 x3 x1, and of course a minus sign with x1 x2. So this is what you have. So from each column, if you see the columns, every column is having the same terms, but of course some minus sign is prevailing in one of those. So if you see, all these three terms are identical, but of course with a minus sign in the last row. Similarly, these three terms are identical with a minus sign in the second row, and of course these three terms are identical with a minus sign in the first row. So if you could try to solve this, we can have, you can take x2 x3 common from this complete column. Similarly, this x3 x1 common from this complete column, and also x1 x2. So if you solve this, we have x1 square x2 square x3 square. Of course, because when you take this x2 x3, we have x2 into x3 into x3 into x1 into x1 into x2, which is nothing but squares of this, divided by x1 square into x2 square into x3 square. So now if you solve this, minus 1 1 1 1 minus 1 1 1 1 minus 1. So anyhow this value is 1. So this is the determinant that you need to find. So please try to calculate what's this determinant and tell me the answer. Please try to calculate what's the determinant of this and try to tell me the answer. All of you. So please try to tell me the answer. What could be the answer for this? It's a simple determinant that you could evaluate. Okay. In my comprehensive course of engineering mathematics, we have solved a lot of determinants. So please try to solve this determinant as well. Okay. But please tell me the correct answer. Okay. See, it's looking, actually the terms are big to write, but actually the problem is very simple. Okay. Just if you know this, then, till this is here, it's common part. Directly, if you know the partial derivatives, you can write this step in a direct way. So once you write this step, this is the second step, and here is the answer. So I think definitely if you calculate, you should get 4. So 4 is the answer for this. Good. Kalimula, Mauli, Akshaya, Divya. So fine. So shall we go for the next problem? I hope things are very much clear with this question for you. Yes? So shall we go for the next problem here? Sai Shavan, good. Solved? Nice. So this is the next problem. So please try to solve. It's a multiple integral, and of course it's a double integral as well. So let's try to solve this. Integral 0 to 2, integral 0 to square root of 2x minus x square, dx dy. Okay. Now, okay, good. Now try to tell me something. Let us suppose on the first integral, means we can clearly see here the limits on the first integral are functions of x. Okay, whenever there is a function of x, can you tell me these are the limits of which variable? Can you all tell me these limits which are here are limits of which particular variable? They are limits of y. Correct? So you know y is equal to 0, and of course y is equal to this thing. So this dx into dy can be written as dy into dx. So no issues. If you write that integral 0 to 2 integral 0 to root of 2x minus x square dy dx. So whenever if you try to evaluate this first integral within this or the inner integral, hopefully now this integration will give you integral 0 to 2. Integration of dy is nothing but y, and whenever you have the 0 to root of 2x minus x square as limits, so now if you simplify the things, you have root of 2x minus x square dx. This is what you have. Correct? So now this is a simple integration, it's a single variable integration. So please try to perform and tell me the answer. So please try to perform this integration and tell me the answer for this. Integral 0 to 2 square root of 2x minus x square dx. This is a single variable integration, correct? Which is very well known to you. So please try to solve this. Look, here you have something like 2 times of x minus x square. Whenever there is x minus x square or something like this, I told you better go for some trigonometric substitutions if you remember, correct? Whenever there is a square root and if you are having minus x square within the square root, then definitely go for some trigonometric substitutions. This is what I told you. So please try to substitute something in terms of trigonometry and try to get the answer. I gave you a hint. So please try to solve this. Today we'll be having some good questions. So please try to solve the questions. Okay. And of course, actually, because of solving all the questions, you know, we are daily solving at least some 15 to 20 questions. So definitely, you know, questions, there can be short test for questions. So we put some good questions. Of course, we do have previous gate questions also. So we'll try to solve. Okay, you're not able to solve this. So shall I solve or you want to solve this? Shall I solve this or you want to solve this integration? No answer. People are busy in solving this. Okay, let me help you out. Look, the integration that's available here is integral 0 to 2 square root of 2x minus x square dx. Correct? This is what you have. Now, whenever there is an x square here, let us take a x common from this. X times of 2 minus x dx. This is what you have. Now, let us take x is equal to 2 sine square theta. Okay. Now, if you take x is equal to 2 sine square theta, and of course, since we are having this x as positive from 0 to 2, we'll take the sine theta is also positive. Okay. So, this implies whenever you take x is equal to 2 sine square theta here, see what happens. Dx is equal to 4 sine theta cos theta d theta. This is what you have. Next, the lower limit is 0 is equal to 2 sine square theta. So, undoubtedly, this theta is 0. Next, if you convert this upper limit, what's the upper limit? 2 is equal to 2 sine square theta. So definitely this theta is pi by 2. Since we are taking x from 0 to 2, which means we know that x is positive, then definitely for given x, this is also positive. So theta changes from pi by 2. So if you substitute all these steps in this particular integral, your integration look something like integral lower limit is 0 again and upper limit is pi by 2. Now this square root of whenever you have taken this x as 2 sine square theta, 2 sine square theta into 2 minus 2 sine square theta. This is what you have. Into next, in place of dx, you have 4 sine theta cos theta d theta. This is what you have. Okay? So if you make a little simplifications here, integral 0 to pi by 2, this is square root of 2 into sine theta, which is root 2 into sine theta. And of course, if you take a 2 common here, then again we'll be getting 1 root 2 into 1 minus sine square theta is actually cos square theta, and the square root of that will give you a cos theta into 4 sine theta cos theta d theta. This is what we have. So now if you bring out all the constants, square root of 2 into square root of 2 is 2 and 2 4s are 8. 8 into integral 0 to pi by 2 sine square theta into cos square theta d theta. This is what you have, correct? And did I tell you any shortcut for this, for calculating integrals of this kind? So please tell me, can you all, did I say any shortcut for solving this kind of integrals? Whenever the limits are running from 0 to pi by 2 and we have sin square theta into cos square theta d theta. Yes? Can you recall this? So if you try to recall 8 into, now here this is even and this is also even, and of course this is 2 and this is also 2. So 2 plus 2, we have 4 into 2 into, of course we can't write 0 next, because if you write 0 then the denominator gets 0 and the total fraction is indefinite. Now if you have 2 here, 1, that's it, finished. Again for this corresponding 2, we have one more 1 into, since both of these are even, we have pi by 2. So if you cancel the things, the answer is pi by 2. Okay, it's a simple integration actually. If you see, this is a simple part and 1, 2 and 3 steps, that's it. Okay, and of course if you know how to evaluate a double integral, by looking at this question itself, you will identify that these are the limits of y. So definitely this is what you will be writing your first step in the answer sheet. Okay, so if this is what you have, then this is some 3-4 steps. Okay, so shall we go for the next part? Shall we go for the next question? I hope things are clear with this question. Okay, so let's go for the next question. Good. So this is the next question. So please try to solve this. It's a question from vector calculus. So please try to attempt this. Phi of xyz is a homogeneous function of degree 3. Okay, this fellow is a function, homogeneous function of degree 3, which means you can clearly say one thing: phi of kx, ky, kz is equal to k cube times of phi of xyz. Okay? This is what you can say. And of course, you can also say one thing: x into dou phi by dou x plus y into dou phi by dou y plus z into dou phi by dou z. This value is equal to 3 times of phi of xyz. Okay? Can I say this? Whenever I know that this phi of xyz is a homogeneous function of third degree, then definitely can I tell these two relations are valid? Yes or no? Please type in the chat box. Can I write these two relations? Yes. If I can write this, now let us go for what they are asking. R bar is equal to xi bar plus yj bar plus zk bar. Of course, this is a j bar, so please correct this. Xi bar plus yj bar plus zk bar. This is what you have. So then the value of divergence of phi r bar. So divergence is nothing but dot product of this del with phi r bar, correct? Which is equal to dou by dou x of phi x plus, because this is nothing but del dot. If you are multiplying phi with this vector point function, we have phi x I bar plus phi y j bar plus phi z k bar. Okay? This is what you have. Yes, if you have this, then definitely the divergence of this vector point function is nothing but dou by dou x of this coefficient of this I bar, which is phi times of x, plus dou by dou y of phi times of y plus dou by dou z of phi times of z. Now, if you differentiate the things partially, look, if you differentiate the things partially, since both these are involving functions of, this phi has some involvement of x here, similarly some involvement of y and some involvement of z even. So now if you integrate it, or if you differentiate the things, we have dou phi by dou x into dou by dou x of this. Means whenever you are treating this x as a constant, you can write x into dou phi by dou x plus phi into 1. Okay? Next, similarly, if you calculate dou phi by dou y, you can write dou phi by dou y into y plus phi into dou by dou y of this y, which is 1 again. So plus similarly here dou phi by dou z into z plus phi into 1. This is what we can have. Okay? Normally, if you apply the UV rule of multiplication, UV rule product of two functions differentiation, then you'll get first function into different. If I write it as x phi, y phi and z phi, then definitely these are the terms you'll be getting. So we have total how many phi's here? Look, we have phi plus phi plus phi, total 3 phi's, and also we have x into dou phi by dou x plus y into dou phi by dou y plus z into dou phi by dou z. So can you all tell me in a total how many phi's we'll be having using this result, which we have already written here? This combination we have somewhere here, correct? X into dou phi by dou x plus y into dou phi by dou y plus z into dou phi by dou z. So this using this combination, and also we have 3 individual phi's here. phi 1, I mean first phi, second phi and third phi. So can you tell me total how many phi's we have here? It's total 6 phi, correct? Look, this is nothing but a simple differentiation which you could see clearly. Normally if these two are functions of x, then whenever you are differentiating partially, we'll be having dou phi by dou x into x plus phi into dou x by dou x, which is 1. Similarly, that things are common for other two terms as well. So 6 phi is the total answer, which is something here. See. Can you all understand how the differentiation of these functions dou by dou x of phi x, dou by dou y of phi y and dou by dou z of phi z looks something like this? Is this clear to all of you? Just we are differentiating partially with respect to x. That's it. Is that clear to all of you? Can you all understand how this is 6 times of phi? Okay. So good. Let's go for the next problem. A very old question, 1997. So let's try to solve this. Let's try to solve this question. So please try to solve this. Good. I'm happy that all of you are understanding the things. So please try to solve this. Finding the limiting value of the ratio of the square of sum of first n natural numbers. You know, sigma n, which is basically the summation of first n natural numbers, is nothing but n times of n plus 1 by 2. Okay? Next, summation of n square is how much? N into n plus 1 into 2n plus 1 by 6. You know this. Correct? So whenever you have n is running from 1 to n, and of course n is running from, let us write for your understanding. Let us convert these two terms. So we can write sigma k k is equal to 1 to n, and of course sigma k square, again k is running from 1 to n. I hope things are better now. So now if you write this, you know these are the two expansions. Now in the question they are asking for the ratio of square of the sum of n natural numbers. So sum of first n natural numbers is this. So square of that is nothing but n square into n plus 1 whole square divided by 4. To this we have n times the sum of squares of n natural numbers. So this is sum of squares of n natural numbers. So they are asking you n times of this number. So n into sum of squares is that. So n into, we have one more n into, so n plus 1 into 2n plus 1 divided by 6. So what they are asking for? Yes, this n tends to infinity. So n approaches infinity. So they are asking for limit n tends to infinity this function. So is there any logic with you to tell the answer of this? Did I give you something? So please look here. This 4 and 6 are constant. So let us take them out of the integration. So if you take them out of the integration, we have 6 by 4 into limit n tends to infinity n square into n plus 1 whole square divided by n square into n plus 1 into 2n plus 1. This is what we have. Correct? So if this is the answer, can you tell me what could be the answer? All of you. So please try to tell me something. What could be the answer here? Look, this is simple. 3 by 2. For these kind of limits, if you cancel this n square, not an issue. Let me cancel with a different ink so you can see. If you cancel this n square, then can you tell me something about the value of this limit? Any one of you? Can you tell me what's the value of this limit? Did we give any shortcut? Whenever n is tending to infinity, did we give any shortcuts to write the value of this answer? 3 by 4 is the total answer, I guess. Correct? That's what you're telling. Okay. And you know, if you expand this, the term with higher coefficient, the term with the highest degree will have the coefficient as 1. And similarly here, if you multiply these two terms, you'll see the term with the higher power of n is 2. So the limit value goes to 1 by 2. Correct? In the first lecture of calculus, I have single variable calculus, I have given you limits, and in limits I gave you whenever this variable is tending to infinity, we have seen how these things happens. So 3 by 2 into 1 by 2. The answer is 0.75. Good. 3 by 4 is the correct answer. Yes, I'm happy for you. Okay. So this is all we have seen the questions. Correct? By looking at this limit itself, you can clearly say the answer is 1 by 2, because whenever you expand this, the highest degree term that comes here is n square. Similarly, the highest degree term that comes here is n square. But here the coefficient of this n square term will be 1, and here the coefficient of this n square term is 2. And we know whenever limit n tends to infinity, if degrees of both numerator and denominator are same, then the ratio of the highest power coefficients is nothing but the value of the limit. We have seen this. Okay? Can you all recall this? Yeah, I think you can recall this. That's why you have answered this correctly. So 0.75 is the correct answer. Next. So please try to solve this. They are asking to find you what is the maximum or minimum or neither things of this function. So please try to calculate this value and tell me the answer. F of x, I mean y is given by x square plus 250 divided by x. So if you want to check whether there is a minimum or maximum, so please try to tell me the answer. What is pi by 2 or Nagsai? I didn't get you. I think you are somewhere lagging, so please try to forward your video, okay? Because pi by 2 is the answer of a question which we dealt long back, okay? So the function y is equal to x square plus 250 by x at x is equal to 5 attains maximum, minimum, okay? Some of you are telling it's maximum and some of you are telling it's minimum. Okay, let me check. Look, you have y dash is equal to 2x minus 250 by x square. Correct? Because if you differentiate this x square, we have 2x, and if you differentiate this 250 by x, this 250 is a constant, and the derivative of this 1 by x is nothing but minus 1 by x square. Correct? So now this is equal to, if you equate this to 0, we will be getting 2x cube is equal to 250. So which means undoubtedly x is equal to 5. Correct? Because if you cancel this, we have 125, and x is equal to 5 is the only stationary point for this function. Now, at this only stationary point, you need to know whether this function will give you a maximum or a minimum. Undoubtedly, one thing you can tell, look, as you keep on increasing this x, after 5, even though this value is getting decreased, but this value will increase very rapidly, correct? This is what you can feel. Normally, if you observe this function, we have something like x square plus 250 by x. Now, let us suppose I put x is equal to 250, then 250 whole square plus 250 by 1, I mean 250 by 250. Can you see this answer is very big, which means the answer is something more than what you will be getting when you substitute x is equal to 5. So definitely this x is equal to 5 is not a maximum for this function. But of course, anyhow, if you would like to go for the second derivative test, then definitely you can see second derivative is nothing but derivative of this 2x is 2 minus differentiation of this 250 by x square is 250 into minus 2 divided by x cube. This is what you have, correct? Because derivative of x power minus 2 is nothing but minus 2 by x cube. So this gets cancelled, and undoubtedly when x is equal to 5, this expression is positive. So whenever this second derivative of y at x is equal to 5 is positive, then definitely this has a minimum, correct? So this x is equal to 5 is the point of minimum for this particular function. If you take any other value of x, definitely you'll be getting something more than what you will be getting when you substitute 5. When you substitute 5, what's the answer? 25 plus 250 by 5 is 50, so 75. If you substitute any value other than x is equal to 5, definitely you'll be getting something which is more than 75. Okay. And anyhow, we have seen the second derivative test clearly. This gives a minimum because the second derivative is positive. Okay. In my basic course of engineering mathematics, means in the comprehensive course, for which the link is already available in the description box, I have given a clear explanation why this second derivative has to be 0. This second derivative has to be greater than 0 for the function to have a minimum value. Okay, with the help of graphs and tangents, I don't know how many of you are remembering that, but I think I gave you that. Okay, yeah, I gave you. Can you all remember? In the comprehensive course, we have discussed why this second derivative at a stationary point has to be positive for the function to possess a minimum value. Can you all remember this from the basic comprehensive course? Please respond. Correct. You can recall the things. Good. Then let's go for the next question. 2014 EC. EC question. Nagasai, I think you're lagging the video. Okay, you better forward so you can attend live. So for 0 less than or equal to t less than infinity, of course, means basically they are telling t is positive and of course including 0. Then the maximum value of the function f of t is equal to e power minus t minus 2 times of e power minus 2t. So this is the function they have given, and they are asking you the maximum value of this function occurs at t is equal to what particular point. So please try to solve this. You know how to differentiate the things, so you know how to check the second derivatives and all. So please try to calculate this. It's an easier question. And of course, it's clearly given t is positive, and of course, this is also including 0 in it. Okay. So please try to answer this. The maximum value of the function. Option A, Jitendra. Akshaya, is it option A? Okay. What about others? Divya, you're to telling it's option A. Okay, let me check. So now, if you try to differentiate this function, we have f dash of t is equal to differentiation of this is minus e power minus t minus, if you differentiate this, 2 is a constant, so 2 into e power minus 2t differentiation is nothing but e power minus 2t into minus 2. So we have a plus into 2. So this is equal to minus e power minus t into, minus e power minus t plus 4 times of e power minus 2t. This is equal to 0. So if you equate this to 0, if you take this e power minus t common, then we have minus 1 plus 4 times of e power minus t is equal to 0. This is what you have. And undoubtedly, it's clearly given for this e power minus t has to be 0. This t should tend to infinity, but of course, it's given t is something finite. So definitely, there's no chance that this goes to 0. Correct? There is no chance this e power minus t goes to 0. So the only thing that goes to 0 is minus 1 plus 4 times of e power minus t is equal to 0. So 4 times of e power minus t is equal to 1. So e power minus t is equal to 1 by 4. So this implies minus t is equal to log 1 by 4 to the base e. So if you shift this minus onto the right hand side, then definitely t is equal to minus log of 1 by 4 to the base e. So this minus 1 which is here, if you shift onto the power, we'll be getting log 4 to the base e. And of course, we have only one stationary point. So whatever its maximum or minimum, definitely it should occur at the stationary point. So at t is equal to log 4 to the base e, we have a maximum value for this function. Okay. Normally, you need to check the second derivative, but of course, here we are getting only one stationary point, and you know, definitely this maximum or minimum occurs only at the stationary point. Then definitely you can conclude this t is equal to log 4 to the base e, which we are seeing here is the stationary point at which this function e power minus t minus 2 times of e power minus t occurs it has a maximum. Okay. Is that clear to all of you with this question? And I'm happy that many of you have answered it A. So let me go for next question. So please try to solve this. It's a 2016 question from EC. So please try to solve this. As x varies from minus 1 to 3, which one of the following describes the behavior of the function f of x is equal to x cube minus 3x square plus 1. So we have a function, basically f of x is equal to x cube minus 3x square plus 1. Okay. So they are asking you whether f of x increases monotonically, or first it increases, then decreases, and again increases. Similarly, decreases, then increasing and decreasing. So they are asking you how could this function look like between these points x is equal to minus 1 and x is equal to 3. So please try to solve this question. Try to have something. How will you decide whether a function is decreasing or increasing? First of all, did I give you something in terms of derivatives to identify whether a function is increasing or decreasing? Yes, did I give you something in terms of derivatives whether to identify a function is an increasing function or a decreasing function? We talked about this, correct? We talked about slope, and I told you slope has to be positive if the function is increasing, and of course slope has to be negative whenever the function is decreasing. So let us try to calculate the derivative of this. So if you calculate the derivative of this, this is 3x square minus 6x. Correct? Now let us have the points. First thing, one thing is very clear. You can see if you equate this to 0, we have two stationary points, x is equal to 0, comma x is equal to 2. These are two stationary points, and of course, fortunately, these two stationary points are lying within this minus 1 to 3. Now, if you try to answer this question, look, f dash of x is equal to 3x square minus 6x. Now, if you take a 3 common, we have x square minus 2x. Now, let us consider the cases for both x square minus 2x greater than 0 and x square minus 2x less than 0. This is what we have. So, if you solve this, x into x minus 2 is less than 0. So, definitely 0 less than x less than 2. Next, if you try to solve this, x into x minus 2 is greater than 0. This means x should be less than 0 or x should be greater than 2. This is what you have. Correct? So, whenever x is greater than 2 or whenever x is less than 0, then definitely you have things like this. So, whenever x is less than 0 and x is greater than 2, your derivative is positive. And of course, whenever your 0 less than x less than 2, your derivative is negative. Which means, can I tell one thing here? If I try to plot these values, 0, maybe x is equal to 2 is somewhere here, and 3 is somewhere here, minus 1 is somewhere here. Now, for every value between x less than 0, the function is positive, means increasing. Correct? So, can we write something like the function is increasing till x is equal to 0, but from between 0 and 2, the function is again decreasing because you can see the derivative is less than 0. So, if this is 0.2, of course, at x is equal to 2, let us calculate the value of this function. So, at x is equal to 2, first of all, at x is equal to 0, the value is 1, okay. So, there is some positive value. At x is equal to 2, 8 minus 12, which is minus 4 plus 1 minus 3. So, we can see at x is equal to 2, this function again decreases to some value. And after this, whenever x is again greater than 2, the derivative is getting positive. So, the function again increases. So, we can see, first of all, it's increasing, and then it decreases, and then it again increases. Okay? Can you all understand this logic with the help of these derivatives? Yes or no? So, please respond. Can you all understand this logic? Why this function is, first of all, it's increasing, and then it's decreasing, and again it's increasing? Clear? Yes or no? So, please try to respond. So, first of all, it increases, then it decreases, and again it increases. So, option B is the correct answer. Okay? Because I told you clearly, for the function to be increasing, its derivative has to be positive. Correct? And we have seen how that should happen in this course also. We have seen in basic calculus, I mean in the comprehensive course, and in the PYQ revision series also, we have seen why a derivative has to be positive for the function to increase. Okay? So, next. Yeah. So, please try to solve this. It's a double integration. So, please try to solve this question. Let I is equal to something, it's given here. So, I is equal to integral, I mean some constant c into integral or the region r x y square dx dy. Or maybe you can write dy dx, doesn't matter depending upon the limits that you write. So, please try to solve this and try to tell me what's the value of c here. Because they are asking you for I value and they have already given you what is c. C is equal to, they have given 6 into 10 power minus 4. 6 into 10 power minus 4. So, please try to calculate this integral and tell me the answer. It's a question from 2017, one of the recent years. So, please try to solve this. I is some integration which is given by some constant multiplication into double integral over this region which is bounded by this curves. Y is equal to 2x, then x is equal to 1, x is equal to 5, and of course x axis. So, you can tell. Look, for the simplicity of the question, you can change the order of integration. You can write dy dx, okay? Dy dx, and of course, if you write dy dx, it's known to you that you will be considering a vertical strip here. So now, if you see, the lower limit of this vertical strip is governed by this x-axis, and the upper limit of this vertical strip is governed by this line y is equal to 2x. Okay? So if you try to write the limits, you will be having y is equal to 0 to y is equal to 2x, and of course, you can see x is running from x is equal to 1 to, oh, I think I'm using the same color. So x is running from x is equal to 1 to x is equal to 5. So x is changing from 1 to x is equal to 5. So please try to integrate this. So every second derivative is negative, does mean function is always increasing. No, we are not talking about second derivatives. We are talking about the first derivatives. Okay, Arun? No, look. I'll tell you something. Whenever a function is increasing and is decreasing, then definitely it has, there can be functions like this. Yeah, something similar to this. Whenever you have a continuously increasing function and of course continuously decreasing, then you will be getting some point of an extremum here. Okay, that's what you can tell. Approximately unity. What is approximately unity? Option A. Okay, this Nagsai is trying some previous questions. Okay, so let me try to solve this. So now if you integrate this, we have I is equal to c times of integral 1 to 5 the integration of xy square dy, and whenever you are integrating with respect to y, you will treat this x as a constant. So x into y cube divided by 3 within the limits 0 to 2x dx. So now if you integrate this, I is equal to c times of integral 1 to 5 x, this by 3 you can write it outside, so c by 3 you can write it outside. So x into, whenever you are substituting this 2x here, we have 8x cube. So 8 also, if you write it outside, we have x cube dx. Okay, so now you can integrate this easily. So please try to integrate and tell me the answer. I think you should get something around 0.999. So even if you are rounding off to 2 decimals, 0.99 would be the correct answer. Okay, yeah, 0.99 is the correct answer. Okay, they didn't ask you to round off, they just asked you to give the answer up to 2 decimals. Okay, so this is how you can evaluate. Okay, yeah, 0.99. Next, please try to solve this question. This is a very good question. It was asked in GATE 2015 for computer science. So please try to solve this. Look, they have given choose the most appropriate equation for the function drawn as thick line in the plot below. So now if you see, we have a function here, and of course the thick line is this one here. You can see there is some thick line here. Apart from the axis, you can see there is a thick line here, and of course the graph is looking something like this. Yes? Yeah, along this line basically. So the graph is looking something like this. So now please try to tell me what could be the answer. Option D, Divya? That's what you're telling? You're feeling option D is the correct answer for this? Look, I'll help you out with this question, and this is a really good question. Before I try this, let me give you some time to solve this. Please try to solve this question. So please try to solve this question. It's a very good question. They are asking you, they have given you one graph, and what out of these 4 options could be a very approximate value for the function corresponding to this graph. Kalimura, you're telling it's B. Okay. What about others? Give your try. Okay. Please try to think carefully. Let's see. Whenever you start solving every question, feel that this question came in GATE 2021 and try to solve. Okay. Option B, Umesh. Fine. Next, any others to answer something? Okay, let me help you. Look, if you check the first option, x, okay, let me change the color. So, x is equal to y minus mod y. So, can I write this as x is equal to 0 when y greater than or equal to 0, and whenever y is negative, we have 2y for y less than 0. Can I write this? Because if I expand modulus of y depending upon y is positive or y is negative, whenever y is greater than 0, this mod y is nothing but y. So y minus y will give you 0. Similarly, if I assume this y is negative, then mod y will be minus y, and whenever you substitute minus y in place of this mod y, y minus of minus y will give you a plus 2y. Correct? Yes or no? Can you understand this? Next, let's go for the second option. X is equal to minus of y minus mod y, which means it's simple. If you put a minus signs here, that's the answers. So x is equal to 0 for y greater than or equal to 0, and of course a minus 2y for y less than 0. Similarly, if you do for other things, one thing is very clear: this C and D will give you wrong answers. Correct? Because look carefully. Whenever y is positive, if you take this mod y is equal to y, then x is equal to 2 times of y. Means whenever your y is positive, you should have some value for x. But in the graph, you have seen whenever this y is positive, means once this graph passes this horizon, there is no x coordinate for the point. Correct? You can see only there is a y coordinate, which means x is equal to 0. Means for every positive value of y, we are having x is equal to 0, which is not possible by these two options. Correct? Because these two options will give you some value for x whenever y is greater than 0. Now, out of these two options, one thing is very clear. Some part of the graph is lying in the fourth quadrant, which means whenever x is positive, y should be negative, which is not possible in this case. Correct? So this is wrong, but of course, only this is the correct answer. So B is the correct answer. Okay. Can you all understand why B is the correct answer? Because if you expand this mod y in terms of y or minus y, these are the two functions we are having for option A and B. And of course, option C and option D gets failed because whenever these two options indicate that whenever y is something positive, you have some finite value for x, which is not the case in this graph here. Okay. Yeah, you can interchange. So you can write whenever y is equal to 0, I mean y greater than or equal to 0, you can have x, and y less than 0 is 2y. But anyhow, better if you see x is the dependent variable and y is the independent variable. Okay. So can we go for the next problem? Is this question clear to all of you? Can you all understand why this graph is denoted by this particular equation B? Because of that logic? Yes or no? So please respond. Can you all understand why this option B is the correct answer for this question? If you all can understand this, we'll move for the next problem. Okay. And of course, if you're liking the videos on this channel, you please like the sessions, and also you can share them among your circles so that the reach gets increased here. Okay. So let's go for the next problem. Again, a 2015 computer science question. So please try to solve this. It's a good question. I think there should be some change in the options B and C because both of them are same. So I think there is something missing here. So anyhow, let's try to solve. So please try to solve this and tell me the answer. This is a really good question. So please try to solve. So please try to solve this question. A times of f of x plus b times of f of 1 by x is 1 by x minus 25. Okay, that's what the question we have. I could see in the chat box. So integral 1 to 2 f of x dx. What's the value of integral 1 to 2 f of x dx if f of x is given by this particular relation? You have only one equation and one unknown, so you can solve. The unknown is f of x, so you can calculate what is f of x from this function. If you know f of x, you know what is f of 1 by x also. Correct? So please try to solve. This is a good question from 2015. So please try to answer this. If a non-zero x, one thing is clear, x is a non-zero. A times of f of x. Can you tell me what happens if x is 0? In the question, in the beginning of the question, we have given for non-zero x. Can you tell me what happens if x is 0? What's the problem that we'll face if x is 0? Any one of you? Can anyone tell me why it's given in the question for some non-zero x? What happens? What's wrong if x is equal to 0? Any one of you? You're not able to answer this? Okay. You have this x in the denominator here and also here. Okay. So whenever if x is 0, then those two values will tend to infinity and you won't be dealing in finite values. So for some non-zero x. So whenever x is non-zero, it's clear these two are finite, and of course a is not equal to b. So all these options are valid because if a is equal to b, then definitely all these options are having denominator as 0. So we can't solve. Indeterminate. Good. Okay. So try to answer this question. Option A. Look, I'll help you out with this question. See, you have a into f of x plus b into f of 1 by x is equal to 1 by x minus 1 by x minus what's the thing that's given in the question? Minus 25. Okay. So minus 25. This is what it's given. Okay. Yeah, we'll see what to put in place of f of 1 by x and all these things. But for the time being, please stay focused here because this is a good question. So let's try to answer this. Look, can I write a times of f of 1 by x means we put 1 by x in place of x. So a times of f of 1 by x plus b times of f of in place of x. If you substitute 1 by x, again you will be having f of x is equal to in place of 1 by x. If you substitute this minus 25 because this is a constant, it never changes. Now, can we do one thing? From these two equations, if I multiply the first equation with a, I'll be having a square plus ba. Again, you have a here and of course a 25a here. Okay. Similarly, if I multiply this with b, a times of b plus b square bx minus 25b. This is what you have. Okay. So now, if you try to subtract these two equations, one thing is clear: this ba into f of 1 by x and this ab into f of 1 by x gets cancelled. Okay. So now we have a square minus b square of f of x is equal to, now you can simplify the things, a by x minus bx plus 25 times of b minus a. This is what we have. Yes, can you all agree with me till this particular step? Which means, can I write f of x is equal to 1 by a square minus b square, which is here, into a by x minus bx plus 25 times of b minus a. Can we write this till this moment? Now you got an expression for f of x. Now we can integrate this between whatever the limits they gave you. Can you all recall this? First of all, can you all understand this problem till this part? Yes or no? So please try to respond. Can you all understand this problem till this part? Can you all understand this? Okay, so if you can understand this, please try to go for integration. If you know what is f of x, so these are simple functions: integration of 1 by x, integration of x, and integration of a constant. So you can please integrate and tell me the value. What could be the answer out of these 4 options? And I think they are asking for some integration of, what are the limits? 1 to 2. Okay, 1 to 2 are the limits. So integral 1 to 2 of f of x dx. This is what they are asking for. And now you can integrate. So please try to integrate this between 1 to 2. So this 1 by a square minus b square is a constant, so there is no issue with this a square minus b square into integral 1 to 2 a by x minus bx plus 25 times of b minus a dx. So if you integrate this, you can calculate value. See, simple 4 steps we are writing, but a careful steps. Okay. So this is equal to 1 by a square minus b square into integration of a by x is nothing but a times of log x within the limits 1 to 2 minus integration of bx is b by 2 x square within the limits 1 to 2 plus 25 times of b minus a into x, of course within the limits 1 to 2. So if you can calculate this value, you will be getting one of the options given in the question. So please try to calculate this. This is equal to, let me draw a line in between again. Okay, so now if you try to continue, 1 by a square minus b square into, now if you calculate this value, log 2 minus log 1, and log 1 is anyhow 0, so log 2 is the only thing that's retained here, so a times of log 2 minus, if you substitute 2 here, minus b into, or b by 2 into, if you substitute a 2 here, then 2 square minus 1 square will give you 3 plus 25 times of b minus a into 2 minus 1, which is something like this. So now if you simplify the things, you can have 1 by a square minus b square into a ln 2 minus 25, a times of ln 2 minus 25. This is what you have, plus, I mean, of course, minus 3b by 2 plus 25b. So 25 minus 3 by 2 is nothing but 47 by 2. So plus 47b by 2. This is what you have. Okay. And I think there's nothing much simplification to do now. I think one of these things should be there in the options. Okay. So now we have done two simple integrations. I mean, if you know this, then there is no need of writing this step. You know, directly you can write this on the right hand side. Okay. So 1 by a square into a into ln 2 minus 25 plus 47 b by 2. 1 by a square minus b square into a into ln 2 minus 25 plus 47 b by 2. I think the answer is straight away in first option. Option A could be the correct answer. Okay. Can you all understand this? Can you all understand this? Or is there any difficulty at any point? Okay. There is nothing difficulty actually. The only thing is there is one equation and one unknown. The unknown is f of x. So you need to calculate f of x by some logic, which is something like this. Okay. Multiplying the first equation with a and second equation with b, then calculating what is f of x. That's it. If you know what is f of x, you know how to integrate this from 1 to 2. Okay. I hope things are clear. Let's go for the next question. I think I have uploaded this complex calculus complete notes as a single document. Did you all get that in the Telegram group? I have uploaded it. Did you all get that document in the Telegram group? I have, I already uploaded that. Okay. Today afternoon around 1 o'clock I uploaded, so I think many of you could be able to see that. So now they are asking for the directional derivative. It's a question from vector calculus. So again, let us try to calculate what is the directional derivative and all. So this f of x comma y is equal to xy divided by root 2 times x plus y at 1 comma 1. Of course, they are asking this value at 1 comma 1, and of course in the direction of unit vector at an angle of pi by 4 with y axis. So they are talking about a unit vector at an angle of pi by 4 with x axis. If this is making an angle pi by 4 with x axis, then definitely this also makes an angle with, say, it also makes 45 degrees with x axis. And since this magnitude is 1, you can write this as cos pi by 4, which is 1 by root 2 comma 1 by root 2 as the point of this. So the vector is I bar. You can write a bar as 1 by root 2 I bar plus 1 by root 2 j bar. This is what you have. And of course, this is the function. That's the point. So directional derivative is nothing but gradient of this function f at 1 comma 1 dot a cap. This is what you have. Of course, the magnitude is of 1 unit. So definitely this can be written as dot a bar as well. Correct? 3 is the answer, Mauli. Is 3 the answer for this? Look, if you calculate what is gradient of f, okay. Kalimula, you also telling it's 3. xy, okay, let me try to solve this. Del f is nothing but del of xy by 2. Is this the function they have given? Xy by root 2, okay. Xy by root 2 into x plus y. This is what you have. So if you multiply this, gradient of x square y plus xy square divided by root 2. So this is what you have. So you can differentiate the things easily, and things are very simple here. You will get 3. If you integrate, if you apply gradient on this, then dou phi by dou x of I bar of this function, which is dou phi by dou x of I bar for this function. Dou phi by dou x, if you take y into 2x plus y square divided by root 2 into I bar plus, again if you differentiate with respect to y, x square plus 2xy with respect to j bar. And of course, if you are calculating this value at point 1 comma 1, then definitely this is equal to 2 plus 1, 3 by root 2 I bar plus 3 by root 2 j bar. And of course, the vector that we have is directional derivative is equal to 3 by root 2 I bar plus 3 by root 2 j bar dot 1 by root 2 I bar plus 1 by root 2 j bar. This is what we have. So if you do the dot product, you will be getting 3 by 2 plus 1 by 2, which is 4 by 2. 3 by 2 plus 3 by 2. So we have total 3 is the correct answer. Okay. Which is, I think options are not given for this. Yeah. So 3 is the correct answer. But of course, it's a question from 2014. Okay. Okay. So is that clear to all of you? Are you all clear with this question? It's a very simple question, of course. So 3 is the correct answer, and I'm happy that many of you have solved this. Good. Next, let's go for the next problem. 13th. The divergence of the vector field 2017 civil engineering. So they have given you some vector field V bar is equal to x square I cap plus 2y cube j cap plus z power 4 k cap. At x is equal to 1, y is equal to 2, and z is equal to 3. So please try to solve this. They are asking you for divergence, means del dot x square I cap plus 2y cube j cap plus z power 4 k bar. And of course, at the value of x is equal to 1, y is equal to 2, and z is equal to 3. So this is equal to, now the partial derivative of this x square is nothing but 2x with respect to x, and whenever you differentiate this with respect to y, you have 6y square plus that. When you differentiate with respect to z, you have 4z cube. Right? X is equal to 1, y is equal to 2, and z is equal to 3. So if you simplify this, please calculate the value and tell me what's the answer. 134 Mowgli. So x is equal to 1. So 2 plus 6 into 4, 24 plus 4 times of 27. So this is 26, and this, if you see, 4 sevens are 28 plus 10, 108. So 108 plus 26, which is 134. Yeah, 134 is the correct answer. It's an easier question, but it was asked in 2017 for civil engineering. Okay. This plus, I think you can write a bit more. Okay. Yeah, good. Mauli, Kalimula, Jitendra, all of you. So can we go for the next part? Can I go for the next part? Are you all clear with this solution for this particular question? So please respond. Are you all okay with this question? Okay. So now let's go for the next problem. Again 2017, but of course from chemical engineering. So let I and j are the unit vectors. Here some I is missing. So I bar and j bar be the unit vectors in the x and y directions respectively. For the function f of x is equal to something like this. The gradient of the function is given by. It's a very simple question, but of course it's a previous gate question. So please try to solve this. They are asking you for gradient of x cube plus y square. A very simple question, but of course a previous gate question as well. So you can see this is a previous gate question from 2017 for chemical. So please try to answer this. C is the correct answer. Mauli, Divya. So it's a very simple question. So the partial derivative of this means dou by dou x of this function x cube plus y square I bar plus dou by dou y of x cube plus y square j bar. So if you calculate this value, then you have dou by dou x of this complete term is 3x square I bar plus dou by dou y of that is nothing but 2y j bar. So yeah, we have it in option C, correct. So C is the correct answer. Okay. And of course, it's a simple question of finding the gradient. That's it. Next, 2014, gate 2014. So they are asking you for some integral, and of course, it's a double integral, and it's a closed path involving only two variables. Look, let us try to solve this. They are asking you for cyclic integral C by dx, and of course, they have also given in counterclockwise direction. So anyhow, by default, we'll take the counterclockwise direction. So cyclic integral C y dx minus x dy. And of course, C is nothing but a circle with center at origin and radius is equal to 1 by 2. Correct? So this is a circle at center origin and radius is equal to 1 by 2. So this is x-axis and if this is y-axis. Now, since only two variables are involved, and of course you are calculating a line integral, means along the curve you are integrating. So can we apply some theorem here? Is there any possibility for us to apply some theorem at this point? All of you. So please respond. Is there any feasibility for us to apply any theorem? Yeah, we can apply. Which theorem we can apply? All of you. So please respond. What theorem you can apply at this point? We have a line integral only in terms of two variables, and of course the path is closed. So we can apply Green's theorem. So if you apply Green's theorem, then this is equal to, if you treat this as m dx plus n dy, this is equal to integration over the region r dou by dou x of n, which is given by minus x, minus dou by dou y of m, which is something like this. Correct? M dx plus n dy. So dou n by dou x minus dou m by dou y. So this is what you have. Dx dy, and of course this is minus 2. So this is equal to double integral over the region r, where r is this region bounded by this closed path C, then minus 2 times of dx dy. So whenever this minus 2 is a constant, you can bring it out of the integration. So if you bring it out, we have minus 2 times of integral over the region r dx dy. Now, can anyone tell me what could be the value of this integration? Can anyone tell me what could be the value of this integration? Double integral dx dy. What does this tells us? This represents, this double integral dx dy represents, what does it represent? It represents area of this closed path. And of course, since the radius is 1 by 2, its area is nothing but pi r square, which is 1 by 2 whole square. So pi by 4. So now if you substitute here, minus 2 into pi by 4 is nothing but minus pi by 2, which is in option C. Okay. It's a simple calculation. And of course, I gave you many times that this double integral dx dy is nothing but area. So you can directly write area in terms of this. Okay. So is that clear to all of you? Can we go ahead for the next question? Can we go ahead for the next question? So please respond. Okay, good. There are no issues. I'm happy for that. So 2014, again they are asking you easy. Something from complex numbers. So the real part of an analytic function f of z, where z is given by, of course, x plus jy. It's quite common. So the real part of the function f of z, which is having a real part and an imaginary part, of course. So real part is given as e power minus y into cos y. So they are asking what is the imaginary part of this function. So in one class of complex variables or complex calculus, I gave you something called Milne-Thomson method to calculate this, correct? But of course, I told you in gate examination, you need not find all the things. You can just verify the options. So please verify the options. You know one thing, whenever this function is analytic, definitely it should satisfy the Cauchy-Riemann equations, which means dou u by dou x should be equal to dou v by dou y. And of course, u and v are the real part and imaginary part of this f of z respectively. So dou u by dou x, if you calculate dou u by dou x, whenever you're, this is cos x, correct? Yeah, that's what I'm missing here. So this is cos x. Okay. Because e power minus y into cos x is what the real part given, correct? So now if you see this, dou u by dou x is nothing but whenever you are differentiating this function partially with respect to x, you will treat this e power minus y as a constant. So e power minus y into the derivative of this cos x is minus sin x. This is same as dou v by dou y. So can you understand one thing? Can you understand one thing here? Look, I am writing dou v by dou y is equal to minus e power minus y into sin x. Okay? And one thing is very clear, whenever you are having v with respect to y, you should have a sin x term in the option. Okay? Means this v should involve a sin x function, because whenever you are differentiating with respect to y, you will be treating x as a constant, means there is some involvement of this sin x in this function v. Correct? So which means this first option is wrong. Right? Yeah, this first option is wrong. And of course, all the other options have sin x. Now see which option will give you this minus e power minus y into sin x. This option is also wrong because it has minus e power y. So which is wrong. So definitely this is the option which gives you the partial derivative with respect to y as minus e power minus y into sin x. Okay. Is that clear to all of you? Can you all understand why this v should be equal to e power minus y into sin x? Because sin x can be treated as a constant and the derivative of this e power minus y will give you minus e power minus y. Okay. If you take this option, this minus sign gets eliminated here. Okay. Because of there is one more excess minus. In polar coordinates, I told you, right? in last class also, dou u by dou r is equal to 1 by r dou v by dou theta, and of course dou u by dou theta is equal to minus r into dou v by dou r. We have seen this, okay, in polar coordinates. Koch, I have any questions in polar coordinates? I have already given you this when we are talking about analytic functions. Okay. So is that clear to all of you? So can I go for the next question? So can I go for the next problem? Yes. Good. So it's an old question again, 1994, but of course a differential equations question. So they have given you some differential equation which looks something like ei d power 4 by dx power 4, which is the fourth derivative of x basically, plus p times of d square y by dx square plus k times of y is equal to 0. This is what they have given, and of course they have given e, I, p, k are functions of x only, means there is no involvement of y in this term, similarly in this term, and also in this k. Now, if there is no involvement of y in ei, p, and k, can I call this equation a linear equation? Yes or no? So please tell me, can I call this equation a linear equation if there is no involvement of any y in this ei or p or k? Yes or no? So please respond. Yes, we can call this a non-linear, I mean, it's a linear equation. Okay, and of course, it's clearly visible that it's a fourth order. So A is the correct answer. Okay. Fine. But actually, it's a homogeneous equation. You can see right hand side is 0, and there's no involvement of any f of x individually here. So definitely, it's not non-homogeneous, but of course, it's a homogeneous differential equation. We have defined how to identify a higher order differential equation to be homogeneous or non-homogeneous. Okay, we have seen that. So this is basically linear, fourth order, and of course, a homogeneous differential equation. Correct? So in this option, it's violating the linearity reason. So this is wrong. In this option, it's violating the homogeneity reason, which is wrong. And of course, here they're talking about fourth degree, but actually the degree is 1. Okay, so this is also wrong. Okay, so I gave you reasons for why B, C, D are wrong actually. Okay, how to find non-linear, sir? I told you in if you want to confine whether a differential equation is linear or non-linear. If the equation is linear, then it should not involve higher powers of x, higher powers of y and also higher powers of derivatives of y. Correct? I told you you should not have terms like y square, y cube, or maybe things like dy by dx whole square, dy by dx whole cube, d square y by dx square whole square, things like this. You should not have things like this, any of this, and also you should not have y into dy by dx and all these terms. This are also not permitted. Okay, basically you should not have non-linear terms or higher order or higher degree terms of dependent variable. Means here, if you see y is the dependent variable because you are writing dy by dx, so definitely y is the dependent variable. Means in any of the term you should not have a higher degree term involving y. Okay, or you should not have any terms of y involving higher powers of y. So that's what you can write. Next, this. I think there is some question. 2013 mechanical. Okay. Next, so solve this question. The solution to the differential equation, of course, it's a higher order differential equation. We got a second order differential equation where k is constant, of course, subject to the boundary condition u of 0 is equal to 0 and u of L is also equal to u. U of L should be equal to u, and of course u of 0 should be 0. Now, if you try to check options, there is nothing used for this question except this fourth option. I think you'll be getting the same answer for all the things. Okay. So fourth option, of course, you can eliminate using the options, because if you put x is equal to 0, you should get u is equal to 0. But if you put x is equal to 0 here, this is u times of 2 by 1 plus e power kl, which is not same as u. So that's why this is wrong. Which is not same as 0. So this is wrong. So D is definitely wrong. Okay. But for options A, B, and C, you can't tell using this thing. Okay. Because this option, when you substitute x is equal to 0, this numerator will be 0. So this can be 0. Yeah, it can be of varying with respect to any independent variable. It doesn't matter only if you have dy by dx or dy by dt, something like that. The only thing our concern is this is the independent variable, and of course this is the dependent variable. That's it. Fine. What about the answer for this? Any one of you? B, Divya? Okay, there's a chance B could be an answer. Similarly, there's a chance for A could be an answer, and of course C. Look, let me try to solve. If you write the auxiliary equation, of course, since this is a homogeneous differential equation, let's try to write the auxiliary equation. M square minus k times of m is equal to 0. This is what you have. So m times of m minus k is equal to 0. So m is equal to 0 comma k are the roots of auxiliary equation. So if these are the roots, then definitely the solution is u is equal to c1 e power 0 into x plus c2 e power k into x. This is what you have. So u is equal to basically c1 plus c2 into e power kx. This is what you have. So you can identify what are the values of the constants c1 and c2 basically. Okay. So please try to calculate what are the values of c1 and c2 and try to tell me the answer. Look, you have u is equal to c1 plus c2 into e power kx, and of course u of 0 is equal to 0 and u of L is equal to L. That's what they have given here. So u of L, sorry, is equal to capital U. Okay. So this is not L, but this is capital U. So this is what you have. Okay. So now if you try to integrate, if you try to calculate the values of C1 and C2 using those two boundary conditions, let's try to find the values. So 0 is equal to C1 plus C2, because whenever you put x is equal to 0, this exponential function will go to 1. So one thing is clear, C1 is same as minus C2. Next, if you put x is equal to L, you have u is equal to C1 plus C2 e power KL. Okay, and of course here you have a capital U now. So this implies capital U is equal to, since C1 is same as minus C2, so minus C2 plus C2 into e power KL. So C2 is equal to U divided by e power KL minus 1. This is what we have. So C1 is nothing but minus U divided by e power KL minus 1. So if you substitute these two things in this, we have U is equal to C1, which is given by U by 1 minus e power KL plus C2, which is again U by e power KL minus 1 into 1 into e power kx. So if you take the things common, you will be getting U times of 1 minus e power kx divided by 1 minus e power k. That's what we have. Correct? Nagarjuna Reddy, it's quite possible that you can get a very good rank. Okay. You know, every course is available for free in YouTube nowadays. Okay, so please try to go for that. Okay. And whoever is in the first, second years of engineering, I'm strongly suggesting you, please, don't read this, what are they, previous paper books or something like that for attempting your BTech exams. Please try to learn the concepts. Okay. Try to study some standard textbooks, because BTech is the only time where you'll be getting, a very good time to study or revise all the good concepts and some good textbooks. After BTech, every time, every 3-4 months, you'll be having an exam and you will be in the rush to solve some questions. That's it. Okay. So please, if you are in the starting stage of your BTech in the first year or second year, please, I'm suggesting you refer some standard textbooks, try to learn some good concepts and try to have some good knowledge on the subject. Okay. So please do that if you are at the beginning. And of course, third and fourth years, it's quite common. You won't be getting enough time with your campus placements and projects and whatever. So definitely, please try to, at least use that enough time. Okay, use some good time and refer some good books in the free time at least. Okay, so this is what we have. Finally, we got option B as the correct answer. As many of you are telling this. C1 is negative, sir. Here, yeah, it's an arbitrary constant, and of course, C1 is something like this. C1 is minus C2. It's possible that if C2 is negative, C1 is positive, or if C2 is positive, C1 is negative. But these are the functions that are given here. Okay, depending upon the value of k, it completely depends upon what's the value of this k. It's only given k is a constant, but depending on what the value of k, this positivity or negativity of the functions depend here. Okay. Next, let's go for the next question. Again, a 2016 question, a differential equation. Of course, it's a homogeneous again. So please try to calculate this. Auxiliary equation is, complementary function. If you write c1 x plus c2 e power minus 6x. This is the complementary function. And of course, I think all these are in that format. So you apply these boundary conditions. What is dy by dx? Y dash is equal to c1x plus c2 into e power minus 6x into minus 6 plus e power minus 6x into c1. This is what you have. So if you take e power minus 6x common, you have minus 6 c1x minus 6 c2 plus c1. So you have y and you have y dash. So substitute the boundary conditions. Given y of 0 is equal to 3. So if y of 0 is equal to 3, this equation implies 3 is equal to, when you put x is equal to 0, this term is completely 0. So c2 is equal to, c2 into 1. That's what you have. So c2 value is 3. So if you put c2 is equal to 3 and this derivative is equal to minus 36, you can get what's the value of c1. So please try to calculate and tell me what's the values of c1 and c2. And of course, here they have given the constant value as 3 in all the cases. So there is no use of calculating c1. c2. So try to calculate what's the value of c1. You know this dy by dx at x is equal to 0. Whenever you put x is equal to 0, this term is 1. This term is 0. So 1 into c1 minus 6c2. c1 minus 6c2 is equal to minus 36. Okay. So c2 value is 3. So this is 18. So minus 36 plus 18, which means c1 is equal to minus 18 again. So 18 is here. So option A is the correct answer. For mathematics, as I told many times, you can always go for B.S. Gavel or Erwin Kwasik. Both are very good books. And of course, there is one more book by B.V. Ramana. That's also a decently good book to refer all your basics. Okay. Option A, correct. That's what I have marked here. So A is the correct answer because you are getting the value as C1 is equal to minus 18. Okay. Yeah, good. A is the correct answer. The only thing is you need to make a little, careful in this calculations. You need to be a little careful in this calculations. That's it. Fine. So shall I go for the next problem? Yeah, A is the correct answer. So shall we go for the next problem? All of you. So please respond. Can we go for the next problem now? Yes. Okay. Oh, I think they are finished. Okay, good. So we have solved some 19 questions in this cumulative, and of course we have revised all the things. So now, if you recall, from next class, from tomorrow's class, we will be starting the linear algebra, matrices basically. So this is a really important topic, and of course it's common for all the branches. So linear algebra is really a very good topic. So please don't miss the classes. Many of you feel it's really easy, but previous gate questions will make you feel that there is something to learn from this topic. Okay, so don't skip classes of linear algebra because you have some very good gate questions which some of you may not be able to solve in the single attempt or the first attempt. Okay, so that's why we are starting this linear algebra from tomorrow. So don't miss the classes. And of course, we are maintaining a Telegram group for engineering mathematics course exclusively. So in this Telegram group, it's a two-way communication. Even I can post something or you can post something. So here we have uploaded all our notes, and of course the notes of this class and all other classes will also be uploaded in this Telegram group. Okay, so please join this Telegram group, and if you're having some doubts you can scan this now. So if you're having some doubts at any moment, you can always post in this Telegram group. Okay, so I and many of our friends will be available in that group to solve your doubts, okay, to answer your doubts. And of course, this is the official information of Engineers Hub. So this is the official website of Engineers Hub. So you can visit this website for any of the information regarding any things that we are going to deal with. And of course, Engineers Hub is conducting a scholarship test that's commencing from 6th of December to 13th of December. So daily, if you are interested in this, you can go to this website. There you will be finding a link to register. Okay, so based on the marks, based on your performance, you will be getting some discounts. But of course, I don't know the exact details, but you will be getting some discounts so that you can join our courses with a reduced cost. And of course, these are two Telegram groups. And of course, these are channels, of course. So all the mechanical people can join this particular channel, and all others who are excluding mechanical, like ECEAA and all others, who is non-mechanical can definitely join this group so that you'll be getting some excess content that's useful to you. And of course, these are official contact numbers, so you can contact to any one of these numbers for any information or any guidance regarding gate or other related issues. So definitely, we are offline at Visakhapatnam. So definitely, if you could like to visit us, we are the most happy to see you in our office. Okay. So this is the cumulative session, and of course, here we have finished some nearly 50 to 55% of the syllabus. So is that clear to all of you? From tomorrow, we'll be having classes of linear algebra. Okay. So don't miss the classes. We'll solve some good number of problems here. Okay. So is that clear to all of you? Can we sign off for now? All of you, can we sign off for now? I hope things are very much clear, correct? Okay then. Thank you all. Good night. Have a nice sleep and time. Bye.